Okay, we're jumping into 7.1 and we're going to be looking at a lot of exponents. We're starting with two properties, the zero and negative exponent properties here. The solve it that you did in class, hopefully it helped explain the why behind why a zero exponent is going to be to the is going to equal 1, and why when we have a negative exponent we are changing it to a positive by moving the term. So whatever I get written down, I suggest you get written down. Let's go ahead and go through these. Can I simplify expressions with zero and negative exponents? So as we look at the definition of a zero exponent, any number to the zero power except 0 is 1. So if I have a -7 in parentheses to the 0, that answer is just 1. If I have a letter, we could say if I had a to the 0 power, that answer is just 1. Okay, if I had a positive number, pick any positive number, let's say 37 to the 0 power, that answer is just the number 1. Pretty easy property. That's it for zero exponents. Let's look at negative exponents. It says to change to a positive exponent, you move the term. So we're going to move between the numerator and the denominator. What I like to do with all of these problems is I want to make them a fraction. So how do we make any number a fraction? We place it over 1. So I start out to make sure that all my problems are written as a fraction. Okay. So we have 9 to the -2nd power. So we want to simplify that by making it to a positive exponent. And so I always say circle the term that's negative and draw an arrow. It's in the numerator, so we're going to move it to the denominator. So we have the number 1 in the numerator, and in the denominator we have 9 squared. We could simplify that. We know what 9 squared is. 9 times 9 is 81. So some of these we can simplify. Let's look at the one below it. We can't simplify if we've got variables necessarily where we get just a numeric answer. The variable might be part of our answer, and that's okay. Let's go ahead and look at the one right below that problem. If I have 1 divided by 3 to the -4th, I'm going to circle what my negative exponent is. I'm going to move it. It's in the denominator, so we're moving it to the numerator. So it becomes a positive exponent. So it's 3 to the 4th power over 1. Now, if we wanted to simplify that, we're taking 3 times 3 times 3 times 3, which is just actually going to be 81 over 1. Do you need to write 81 over 1 as a fraction? No, but I like to leave these in fractional form. I just think it helps to alleviate some confusion down the road. Let's go ahead and look at the ones with our variables. I have 5a cubed b to the -2nd. We are only moving what's negative. So I'm going to circle the negative exponent. The b is the only thing that has a negative exponent, and it's in the numerator, so we move to the denominator. And so what stays in the numerator? What have I not moved or not touched? Well, that'd be the 5a cubed. And what did we move to the denominator? We move the b, and it becomes a positive exponent, b squared. And that is simplified. That's it for that one. Let's go ahead and look at the last one here on this page. We're going to circle what has the negative exponent. It's in the numerator. It goes to the denominator. The m I'm not going to move. The m is staying in the denominator. It's positive. We want to leave exponents positive, so we don't move it. And then the n becomes to the 5th power. So what do we put in that numerator? We're just going to put the number 1. So here we are looking at the negative exponent property. We've got like 2 more examples and we'll be done. Let's go to the next slide. Zero exponents, those are pretty easy. Those are our favorite, right? If anything to the 0 power equals 1. And how we get rid of a negative exponent and make it a positive. Have a good one. So this one's got a lot going on. Okay, this example kind of has a lot going on here. Let's go ahead and kind of circle and identify what we know. Well, there's a couple things that I know here. I know that y to the 0 power is going to just be the whole number 1. So we can kind of cross it out and put a 1. I know that my z is a negative exponent, and that negative exponent needs to go to the denominator. Why? So it becomes positive. And I know that I have a negative exponent in the denominator, and it needs to go to the numerator to become positive. So I just start circling and identifying what properties I have here. So what have I not changed? Well, the 10, x squared isn't going anywhere. Okay. What is going to come up to the numerator so we have a positive exponent? The u to the 5th divided by, and what's in the denominator? The 5 and the z to the 3rd power. What happened to that 1? Well, that all means multiplication. 10 times x squared times 1. So all of that times 1, it's just gone. It is itself. So how do you know that you're simplified? Okay, well, you know you're simplified if you have no negative exponents. You also know you're simplified if you see each letter only written itself one time. So I only see one letter X written, one letter U, and one letter Z. So far we are simplified. I have no negative exponents and I only see one of those. However, I want you to think about what 10 divided by 5 is. These are whole numbers. If I were to just take this fraction out to the side, 10 divided by 5, I think you would all tell me that would be the whole number 2, or we could write it as 2 over 1. So we need to simplify those values, which I just did with you. So our final answer here would be 2x squared u5 divided by, if you want to write the number 1, you can, z to the 3rd power. You don't have to write that 1 in front of the z cubed, but you can. And that would be simplified. The next example, the last example, I would suggest simplifying and then they want you to substitute. So I'm going to start by, remember I like to start with these need to be written as a fraction, so I'm going to place it over 1. That's step 1. And next, let's go ahead and look at my variables here. And I notice that I have a negative exponent. We're going to move it to the bottom. So in the numerator, I still have 3s cubed. And in the denominator now, I have t to the positive exponent 2. And now it's just a matter of substituting. So we have 3, and then the letter s is 2. So I plug in, oops, that's a 3, sorry. Plug in a 2 for that s. And t in the bottom, remember we always substitute with parentheses. And so the top of this is really just saying 3 times 2, 2, and 2. And the bottom is saying a negative 3 and a negative 3. And when we evaluate that, we're going to get a 24 over 9. And it's an ugly improper fraction. If we want to fix that improper fraction, we know it's a whole number 2 with 6/9. And simplified even more would be 2 2/3. A bunch of simplifying for that one. But that's it. That is, if